So I'm going to be doing the second piece of a chemistry overview. This class is an integrated physical science class, so we're doing like a little snippet of all the different kinds of sciences there are to life. And so we are looking, we just finished a unit on physics, and then after that unit, starting like tomorrow, Monday, we're going to do a little, we're going to do a unit over the atom and its, so on some of the atom's structures and qualities, kind of using fireworks as a big idea and looking into some other activities to look into how electrons behave in ionization and orbitals and energy related to that. So that's going to be a really good setup for the unit that I'm going to teach, which is going to be on bonding and reactivity. Mm-hmm. So let's see, that's the context. In a sentence, my big idea is there is this great video by this UK cool science team that they throw they put sodium and then lithium and then sodium and then cesium and then francium into water, and it just has bigger and bigger and bigger explosions, like a bathtub explodes at the end. So that my kind of puzzling phenomenon is that why does this explode? Why does throwing a metal into water cause an explosion? And what do you think is causing that? And what do you think is happening? Or why do you think that's happening? Do you guys have any questions about kind of that question, or a quick clarifying question? Yeah.
I hope you're showing a video of it.
Yeah, but I'm thinking about maybe doing a lab with sodium, because you can do that.
Potassium, you can probably get your hands on. I think cesium might even be a controlled substance because it's explosive.
I don't know if I would want to do that one. Sodium is probably as far as I would.
And then if you have it
venture
in your lab, you
we
don't
do.
have to worry about.
I know we have some.
Yeah.
Anne has some. So okay, this is kind of my understanding of it so far, is that before you put the alkali metal into the water, both are stable in their structures, so they have metallic bonds holding it together, or covalent bonds holding it together, and that the metal is composed of atoms that are not changed in each, that are not charged. So all the atoms in the metal aren't charged at that point. They are in a stable position of sharing of
This is
metallic
before.
bond. This is before.
Oh, okay.
And then all the water molecules are bonded covalently. I'm not going to go into polar covalence, but just
hydrogen bonding at all?
I don't think we're going to get into intramolecular forces. Okay. We're just going to talk about the molecules.
Oh.
So we're going to talk a little bit about what a molecule is, and a little bit about the convention of naming and writing that, H2O, why that's written that way. And then we're going to, so that's kind of the before, why, and so then when the metal is introduced to the water, and so there's going to be a before, during, and after for my eliciting ideas tool, and then also for my assessment. It's going to be kind of a before, during, after kind of thing. So during is, the metal is now in the water, so an electron is transferred from the metal to the oxygen in the water, the oxygen of the water molecule, and then the hydrogen is kicked off of the water, so then there's an oxygen, so there's a hydroxide, there's alkali hydroxide formed, and then hydrogen gas formed. So that's what's going on during the reaction. The reaction happens twice, so we're going to talk about balancing at least we're going to talk about balancing equations, and how to write that equation and how to balance it. And then we're going to also talk about how valence shells go to a lower energy state. It's going to be kind of a review from the chapter before.
Right.
And then we're going to talk about how how the electron, how the configuration of the electrons, like when they give away an electron, that's why it becomes an ion at that point. So talking about how an ion is formed is because of an electron an atom giving away an electron.
Okay.
So and then we're going to talk about products and reactants. So this is like the after explanation. So how reactants in this case would be hydrogen gas and the lithium or alkaline hydroxide, and that sometimes you can not, or that products.
Reactant?
Products. That the products are going to be hydrogen gas and alkaline hydroxide, and that the products are going to be different than the reactants, so that you can make new things.
Oh, cool.
Through reactions. And that sometimes those things can be invisible, like a gas. So we're going to do a lab that's with carbon dioxide and capturing that gas, and then like seeing that it can put out a candle.
So like displacing like the water?
Yeah,
like
displacing the water. Yeah, so it's like
Yeah.
you put an Alka-Seltz in water and you capture the carbon dioxide gas.
One. Okay,
and then you
open
like
it
take it and you put it over a candle and it puts the candle out because
Yeah.
so it's a new
you
gas.
Can even
It's
teach
not-
like a little
it's
bit
not
of like
air.
conservation type thing.
Right,
too,
and you can measure
Yeah.
the mass of that too,
Uh-huh.
which would be really interesting. So yeah, and then it's not air, so it's something else. It's a gas
Yeah.
that's not air, so that gases don't have to just be.
And the reason it
oxygen
puts it out
all the
also
time.
has to do with like density a little bit, so you can even.
If we want to
can
go
teach
into
them
it,
a lot.
yeah,
You
we
can
really
pour it
could.
into a tray on a scale and weigh it.
Whoa.
Yeah, that's true. You really
You can?
could. Yeah, because
That would be pretty interesting.
Yeah, it'll go to the bottom. Yeah.
That would be pretty interesting,
More dense.
and then they can measure it.
Yeah.
Okay, so
If
I'm
you
gonna
set
keep
the
thinking
scale,
about
you
that.
can do that.
Yeah.
We have one, so that would be
Our
pretty
scales
cool.
are so
And so then we could also talk about how atoms can't be created or destroyed. So they can be rearranged, but they can't be created or
Hidden,
destroyed.
sure.
And that's kind of the biggest thing that I want to be able to teach, is that through a chemical reaction, things are rearranged to make new things. So products and reactants are different things.
So you're doing
But-
a lot. You're like it sounds like you're like touching on like
Yeah.
bonding, and then like going into like the bigger picture. Like
Right.
that's cool.
Yeah. So yeah, but the biggest thing is like that things can't be created or destroyed, but they can rearrange through making breaking old bonds and making new bonds to make a bigger, to make a new product and then a reactant. Yeah. So
And so, how much are you going to be focusing, like, throughout this whole thing, you're focusing on the equation, though, dealing with the firework, right? Or,
no, not really. So the
Oh.
fireworks thing is going to be before what I teach. It's going to be always coming
okay,
back to
got
this kind of model. So we're going to do a bunch of activities that are going to keep explaining this model, and like how do you think what we've learned today would help us learn a little bit more about why the bathtub exploded.
Oh, okay, so the big
So-
ideas around the bathtub the
Yeah,
whole
yeah,
time.
yeah.
Okay.
You can keep tying it back to the fireworks though too, because I mean the
Yeah.
the
It's the
propellant
same,
for a
yeah.
firework, the explosive,
Yeah.
is a similar process
Right.
to that, where it's
Interesting.
going from a solid
is true.
and a liquid or solids and solids into a gas.
Right. Oh,
And
interesting.
the expansion of that
That
gas
is
is
true.
what's firing out the firework or blowing it up so that
Oh, that's cool.
That's
Yeah.
true.
Well, we could go back to that because, I mean, it will be fresh in their minds still. So
Mhm.
we want to keep bringing back ideas from the ionization, energy, atom
just
properties
as the
unit.
you know,
Right.
hey,